Okay, so here we go again. Determine the type of growth pattern that is shown by the figures shown here. Write an expression that would give us the nth term in this pattern. So as usual, I like starting by just recognizing the total number of items in each of the steps or the figures. So step 1 has 2 squares in total. Step 2 has 6 squares in total. Step 3 has 12 squares in total. And here are how is it changing? So to go from 2 to 6, that is a plus 4. To go from 6 to 12, that's a plus 6. And I'm going to go ahead and just construct step 4 next. And from what I'm seeing in the pattern, we have growing squares. So we have a 1 by 1, and an extra square we have a 2 by 2, and 2 extra squares we have a 3 by 3, and 3 extra squares. So for step 4, I'm guessing we're gonna have a 4 by 4, and 4 extra squares. So there is my figure for step 4. When I count this all up, I know it's a 4 by 4, so that's 16 plus 4. So it means I would have 20 squares in total, and if I check that out from 12 to 20, that's going to be a plus 8. So even though there's no constant rate, what is something I notice about how the numbers are changing? I can clearly see that there is a constant change in how my rate of change changes. So that's plus 2. This is also a plus 2. And what this means is I can recognize this as representative of a quadratic growth function. So this is showing quadratic growth. Now, let's get into, well, what would step n look like? So if I draw for step n, what I notice is happening is I have my squares on the top. So this is a 1 by 1, this is a 2 by 2, a 3 by 3, and a 4 by 4. And then I have this additional piece of square, which happens to be the step number. So if it's step number 1, there's 1 extra square. Step number 2, there are 2 extra squares. Step number 3, there are 3 extra squares. And step number 4 seems to be 4 extra squares. So what I noticed based on what I'm seeing here is for my yellow portion, that happens to be n in my pattern. That happens to be n. And for my green portion, that happens to be n times n. So if I should draw step n, this is what I'm noticing. This is n, that's n, and then I have 1 row of squares. This is 1 and this is n. So the total number of squares would be given by n squared, and this would be given by n. So the expression that would give us the nth term is going to be n squared plus n, And you could also have used a table of values to show how your numbers were changing. So x, y. There is no step 0 in this case, so we're going to do step 1, 2, 3, 4 based on the pattern that we have. So we had 2 squares, we had 6, we had 12 and 20, and we could see how it was growing. So that was plus 4, plus 6, and plus 8. But additionally, we noticed that there was a constant rate at which our rate of change was changing, which was plus 2, and that made it quadratic.